Hello students, today I am to continue with the chemical language. Today I am going to tell you about the chemical equations. As you know, chemical equations is the shortest way to describe a chemical reaction. So chemical equation is a symbolic form or an icon of a chemical reaction. In my previous video I told you about the skeleton or the format of the chemical equations and also tell you about the balancing of the chemical equation. To know what is the need of balancing a chemical equation, you know the law of mass of conservation. To follow the law of mass of conservation, as the law of mass of conservation tells us, a matter can neither be created, can nor be destroyed. So in chemical reactions, the reactants, the weight or the mass of the chemical reactions must be equal to the weight of the products or the mass of the products. So it is very difficult for us to calculate the mass of the products. We can calculate, we can take a definite mass or weight of the chemical reactants, but it is very difficult to calculate the mass of the mass or the weight of the chemical reactants. So we have an alternative method to balancing the chemical equation, that is by counting the atoms of elements found in the reactants must be equal to the atoms of the elements in the products. So all the atoms in the reactants must be equal to the atoms of the products. So in this way we can balance a equation. So how will you balance the equation? In theoretical there are two methods. One is the by hit and trial method and second one is the partial method. I have told you in my previous video. But to make you more comfortable to balance the chemical equation, I am telling you with the help of the types of chemical reaction. As you know, there are four types of chemical reaction. One is combination. Combination reaction, in my previous video I told you, when two or more compounds or the substance reacts together and to form a one product, that is called as combination reaction. This is the combination reaction. In this case, you can write here 2s2o. I have told you in the 2s2 plus O2 is the 2H2O. This is combination reaction. Again I am telling you, suppose this is sodium hydroxide Na2O, sodium oxide S2O, you will write here 2NaOH. These are the combinations, and I have given so many examples in my previous video about the combination reaction and tell you how will you balance this combination reaction. Now today I am going to teach you about the decomposition reaction. The decomposition reaction is totally against, as opposite the combination reaction. Here only one substance will dissociate into two or more than two products like A, B, and here it is A plus B. It is A plus B. So you can, this is the dissociation. This is the decomposition reaction. The one compound or one substance decomposes into two or more than two substances, that is decomposition reaction. Take the example of potassium, heating the potassium chlorate. So here, when you potassium chlorate. Potassium chlorate. Here, one thing I am telling you here, when I told you when potassium chlorate is heated on 250 degrees centigrade or 260 degrees centigrade, the potassium chloride and the oxygen are formed in the form of products. So write the equation. So how will you write the equation? First of all, you need to know about the formula of the potassium chlorate. And again, in the product, you need to know the formula of the potassium chloride. So, in my previous video, I have told you about the formulation of the different compounds, and go through that video and to learn about the formulation of the chemical compounds. And if you are perfect, or you are perfect in writing these chemical formulae, then you will be able to write the chemical equation. And those whom I am telling you the right, suppose I say you write the formula of the potassium chloride. So one student write potassium chloride, and this one again, someone will write like this, and some will write like this. So if you are confusing, if you have confusion to write the formula, you are not able to write the chemical equation. So first of all, you should learn very well how will you write the formula of the chemical compounds. So to explain with the help of decomposition reactions, this is one is the decomposition when A and B, dissociation to A and B. This is the decomposition reaction. So it is also known as the dissociation reactions. So again, when take an example of the potassium chlorate, this is the potassium chlorate, this potassium chlorate, and when you heat it, it will decompose, or it will be decomposed into KCl and 3O. It will decompose in the KCl and 3O. This is the, and now how will you balance the equation? Now here the atom of the potassium 1 and potassium 1, Cl1, oxygen, these are 3 oxygen, and there are 3 oxygen. So it is a balanced equation. But in my previous video, I told you all the natural gases like oxygen, hydrogen, chlorine, nitrogen, etc. will be written in the molecular form in the chemical equation. So this oxygen should be written in the molecular form, as the oxygen, the molecular formula of the oxygen is O2. Now you will write this 3O into O2, right? You can write here 1.5 O2, but partial number are not allowed to write in the chemical equations. So here again, it means you required 6 oxygen to make it 3O2. When you make the O2, it is 3O2. So for the equation, you will write here 6 oxygen. You will write here 2 KCl plus 3O2. In this way, this is the equation. Again, I am going to suppose when KNO3, sodium nitrate potassium nitrate is heated, it will turn into the potassium nitrite and oxygen. It is, suppose you have taken the potassium nitrate. It is potassium nitrate. When it is heated, it will be changed into potassium nitrite and KNO2 plus O. This is O. And this, how will you write? So KNO3, 1O. Again, this oxygen must be converted into the molecular form. So we'll write, you need 2 oxygen atoms here. So you need 2 oxygen. So you should multiply with the whole equation with the 2, or otherwise O2, and you will know 2K NO3, 2K NO2. So here 2 potassium, 2 and nitrogen atom, 2 into 3, 6 oxygen atom, 2 into 2, 4 oxygen atom, plus 2, 6 oxygen. Then this is our balanced equation. Again I am giving some more example about the decomposition reaction. So here again you take the example when ferrous sulfate, crystalline ferrous sulfate is heated. What will be the form? It is the crystalline ferrous sulfate. This is crystalline FeSO4 and 7S2O as crystal water in the FeSO4. This is called as green vitriol. The common name of this ferrous sulfate is green vitriol. Green vitriol. So it is the FeSO4 ferrous sulfate or crystalline ferrous sulfate. When it is heated, first of all, the color of the ferrous sulfate is light green. So it is known as green vitriol. When it is heated, first of all, this 7 water molecule will be evaporated and it will be formed as FeSO4. 7S2O will be turned into vapors, and so it is the anhydrous acid. So it is white in color. So it is first of all the FeSO4 lose its color and turn into white. Now FeSO4 again, it is when it is heated on higher temperature, FeSO4 it will be turned into Fe2O3 plus SO3 plus SO2. So again, when FeSO4 is heated, so it will decompose into Fe2O3 ferric oxide, sulfur trioxide and sulfur dioxide. You can write here, it is in the form of S. It is again in the form of S solid, and this one is gas, and this one is gas. Now, what will you do next? You must check it whether it is balanced or not. Here, one Fe, atom of iron is 1, here 2. So you should write here 2 Fe. Again here 2S. So here 2S. So here S1 and 1. So it is calculated. Again oxygen, there are 8 oxygen, 3 oxygen, 6 oxygen plus 2 oxygen, there are 8. So this equation is balanced. But now think about how will you decompose, how the decomposition of this ferrous sulfate takes place. So right here FeSO4 like in this form. So there are 2 FeSO4. Here 2 FeSO4. Here write in this form 2 FeSO4. This is your extra work to understand the chemical equation. Suppose this is right here. You need these 2 Fe. These 2 Fe requires 3 oxygen to make ferric oxide. So again 1 oxygen from here, 1 oxygen from here and 2 oxygen from here. So this will be 3 oxygen will combined with the Fe, then Fe2O3. Now when one oxygen released here from when SO4 loses 1 oxygen, then it will be converted into SO3. When this SO4 lost 2 oxygen, then it will be SO2. So this is your extra work to understand the chemical equation. So how the FeSO4 is dissociates. So I understand. Now take the example of another compound. Suppose when lead nitrate is heated, so again it forms the lead oxide, nitrogen peroxide and oxygen. So how will you what is, so first of all, when you try to write a chemical equation, I told you the name of lead nitrate, so you should know the formula of lead nitrate. Without knowing the formula of lead nitrate, you can't write the chemical equation. So first learn the formula. What is lead nitrate? This is lead nitrate. PbNO3 twice. PbNO3 twice when it is heated. So PbNO3 twice is when it is heated. You will get here PbO, lead oxide, plus NO2 plus oxygen. Oxygen writing in the form of an atomic form. If you again in the last to balance the equation, first of all write this oxygen in the atomic form. So now come to it is your extra one. So to understand, PbNO2O and PbNO2O. This is extra one. So this oxygen, so only PbNO3, only one Pb is here. This oxygen will combine with this Pb, the PbO will be formed. This is lead oxide. All the two molecules of the NO2 will be used as NO2. So here 2NO2. Here 2NO2. Again, this oxygen will come out, and this oxygen in the form of. So we find the oxygen in an atomic form. Now we will convert this oxygen into a molecular form. So again we will multiply this whole equation with 2, and again we will write the equation like this: 2PbNO3. 2PbNO3 twice, and it will hit it again 2PbO plus 4NO2 plus, when this oxygen is multiplied by 2, then 2O means O2. This is the balanced equation. How will you try balance the equation? Now I am giving a next example for the example. So I have given some example of the dissociation reactions, and again I am giving you a more example. When lead oxide, when red lead, do you know the formula of lead? Pb3O. Pb3O4. It is red lead. It is called as red lead. When it is heated, this will become PbO. Suppose here 3Pb, and you will form 3PbO. One oxygen will be released here as O. So this oxygen is again in the form of the atomic form. So again, when you write in the molecule, you have to multiply this whole equation with 2. Then it will be 2, and you will write here 2. Again, this 3 will be 6. Then this will be the 2Pb3O4 is equal to 6PbO plus 2. So these are the equations of the decomposition reaction. Next types of the reaction is the displacement reaction. Displacement reaction. I have told you here in the types of the reactions, that is, now I am telling you about the displacement reaction. Displacement is third type of the reaction, so it is the name of the displacement reaction. reactions, displacement reactions. What are the displacement reactions? So these two types of the reactions, one is displacement and coming next is double displacement reaction. These two types of the reaction will help us to find out the name of products. How will you get? Suppose if I am telling you in this suppose it is A and it is BC. These are the compounds. These are the reactants. When A plus BC reacts, when A will displace this B. A will displace this B. So the newly formed compound will be AC. And again here B will be out here. So this is the displacement reaction. It will help us to tell about the nature and the name of the products. So you need not to claim the equations, but from this equation, from this method, you can estimate what will be the product. How? Thus I am telling you, suppose here it is Zn. Suppose here Zn. And I will take the reaction of the HCl. When any metal reacts with any acids, hydrogen will be replaced. So here this Zn will replace this hydrogen. Suppose I am telling you, write the equation when Zn is treated with HCl. You will write Zn plus HCl. Then write the product of this reaction. What will be the product? You will, if you know the displacement reaction or these types of the Zn will replace this hydrogen. You will write here Zn and Cl. So it is newly formed product. So again you have to check the formula of this newly formed compound. The formula of this newly formed compound is correct or not? It is not correct. You have to write the correct formula of the newly formed compound. So here it is Zn, the valency of the Zn1, and here ZnCl2. You should write the ZnCl2. Again, so here you require 2 chlorine here. So you will calculate, and these 2 hydrogen will come out here as 2. So it is the equation. You need to, and now I am saying that what will be the happen when magnesium is treated with S2SO4, dilute S2SO4. This is dilute S2SO4. Then what will be happen? You don't know what will be happen. So as if you know about the displacement reaction, you will say this magnesium will displace this hydrogen. And magnesium will combine with SO4. So MgSO4. MgSO4. Again check the formula of this MgSO4, magnesium sulfate. It is side form. And suppose you have magnesium MgSO4. Again the hydrogen. You will write here hydrogen. Suppose you write the equation is here 2Na, 2S2O, 2NaOH plus S2. You write it. Suppose when sodium is treated with water, sodium hydroxide and hydrogen are formed. To understand this, I am telling you to make you understand. I am writing in this way. Suppose this is Na. To understand, suppose this is Na, and the S2O is here like in this way. S2O you can write H2O you can write in this form HOH. So Na will replace hydrogen. Na will replace hydrogen. So here the formula of the sodium hydroxide NaOH. NaOH, and H will be replaced here in this form, this H. Again, you have to show this hydrogen in the molecular form, so you can double all the equation 2s2, 2NaOH and S2. This is 2Na2S2, 2NaOH plus S2. So it is also a reaction of the displacement reaction. I will give you some more example about this. Suppose take the example of the calcium. When calcium is added into the water, what will happen? You don't know. But if you write the calcium in this way, in calcium, and this is HOH, calcium will replace hydrogen. Calcium will replace hydrogen. Then Ca and OH. So OCA, newly formed compound will be COH, calcium hydroxide. Now check the formula of this calcium hydroxide. So calcium double positive, OH negative. The formula of the calcium hydroxide will be CaOH twice. Now the hydrogen, it means you require 2 molecules of water to form the OH twice. So here this 2 hydrogen will be displaced as hydrogen gas. So when calcium is added into water, the calcium hydroxide and hydrogen are formed. In the same manner, suppose if you very popular reaction, when the iron nails are added in the copper sulfate solutions, the iron nails get converted into yellow. What is the reaction? Now suppose the iron nails Fe. When Fe is added into the copper sulfate solution, CuSO4. So Fe will replace Cu. So this FeSO4. This FeSO4 will be formed. The ferrous sulfate, the newly formed compound ferrous sulfate. So Cu will be replaced as this Cu. This Cu will be deposited on the iron nails. So the iron nail, the color of the iron nails will converted into the yellow. We will see the color of iron nails is yellow. So this is the reaction of this is also decomposition reaction, displacement reaction. So displacement. So here one thing you should know, the element, the nature of this element, single element. Suppose it is positive, so it will replace the positive part of the reactants, and if it is negative, suppose it is a sodium iodide solution. Suppose it is sodium iodide solution, liquid form. So it is when chlorine gas is added. So it will replace the iodine. So here are 2 chlorines, 2 iodine. So here you can write here 2NaCl plus I2 This is the reaction. Again, when you have studied so many equations, suppose there are Na sodium. Sodium is treated with NS2. Sodium is treated with ammonia. So Na, write the formula of the ammonia in this way. Ammonia, HNS2. Na will replace hydrogen. So this will be NaNH2. Sodium amide. This will be sodium plus 1 hydrogen. So here 1 hydrogen, 2Na, 2SH3, 2NNS3, as 2. So I have told you about the reaction, displacement, reaction. These displacement reaction tells us about the formation of the real products. So I think that you have understood about the displacement reaction. I have told you about 3 types of the chemical reaction. One is the combination reaction, second one is the dissociation, and third one is the reaction. So let's end with the video. So do share with your friends this video. This helps you to understand the chemical equations. How will you write the chemical equation? And chemical equation is the base to understand the chemistry or to make the chemistry easy. So this language, if you are eligible to write, to understand the chemical language, then the chemistry will be easy for you. Thank you very much.